Okay, so the AP Calc Unit Exam 3 study packet, I'm going to go through and I'm going to do like one of each type of problem that will be on the test. Now, this exam format, I'm saying here that the order may vary, so like these are the problem types. So I'm going to do this in order. Like for numbers one and the first two problems I do are going to be of this type. The third problem will be of that type. But on the test, they could be mixed up. Like I'm not going to put the hardest problem first, but like there could be some variation in this lineup, but there also could not be. I just don't want you to feel, like the first problem I see is going to be this. The second problem I see is going to be the next. Don't get committed. Don't get attached to that idea because that won't always happen. But this is the format. And so I'm going to do one of each type of problem, and each of these are going to be from the packet. So the first type, finding dy dx in terms of x and y, I'm going to do two problems of this type. And the first one is going to be page 2 of the packet, number 10. Okay, so page 2 of the packet, number 10. Okay, we're going to use implicit differentiation to find that. So those are the directions. Here is the function. Okay, so the derivative of e to the y is, or actually, I don't know, let me go like this. All right, so I'm going to take the derivative of every term of the equation. Derivative of e to the y is e to the y times dy dx, which is y prime. And then this is equal to the derivative of tangent of x is secant squared of x, and then times dx dx, which is just 1. So you only really have to write in the y primes. You don't have to write in, so you only have to write in the dy dx's. You don't have to write in the dx dx's anymore. So there's that. And then I just need to solve for y prime. So I divide both sides by e to the y, and we get that y prime is equal to secant squared of x over e to the y. And I'm going to be going really slow, guys, because I haven't worked these problems out yet, and I tend to make mistakes when I'm rushing, so I'm going to go slow, but speed the video up, if you feel the need. So I think that that's right. Yep. Okay, so that's, all right, so one of the problems on the exam you can expect to be like that, at the same level of difficulty. The next problem we'll do is on the same page, and it's number 16. This is the same topic. We are finding dy dx in terms of x and y. So in terms of x and y means you solve for dy dx or y prime. So I'm going to do this. So what I'm going to do is I'm going to find all of the terms, and this is optional, but I think it might help people. I'm putting brackets. Okay, so I'm doing this to all of the terms. Okay, now, all right, the derivative of this term is 2x, dx dx, but you don't have to write it, minus. Now, this next one, guys, for the derivative of this, we are going to need, this term is itself a product, so we're going to need product rule for that. So I'm going to write it out with, like, I won't do that. I'll just use parentheses. Okay, so this is minus, but I'm subtracting what I get with the product rule. So, and you could do this slower than I'm doing, or faster than I'm doing it, but this, let me talk less. And then this plus, all right, the derivative, so I haven't done this derivative yet. I'll come back and do it in a minute. The derivative of this one, don't need product rule for that, but that's 2y dy dx, so y prime, equals, and then the derivative of this one is just 1 dy dx, so y prime. Okay, now going back through, this is 2x minus 4y plus 4x y prime minus, try to talk less. So I'm not going to explain things as much, guys, like the little things, but please make sure you understand every step I do. Okay. I've got these 3y prime terms, and I want them on the same side. Okay, so I put them over there. And then each of these are a y prime term. So I can factor out a y prime. And then over here. Okay. And then just divide both sides by that factor. Okay. So you can expect to see one that is at that level of difficulty. Okay, so that takes care of this first problem type. Now we're going to find dy dx at a point. Okay, so instead of finding it in terms of x and y, we're going to find it at a point. Okay, so this is page 7, number 12. So we're skipping around a little. Okay, these are the problems from the Larson book. Whoopsie. And we're going to do, okay, so we've got this equation, and we want dy dx at 4, 1. Oh, did I write it down right? Yep. At 4, 1. Okay. Derivative of every term. Okay, for this one I need this. Oh, wait. I'm gonna go like that. Okay, so I need product rule for this, and you need it in parentheses. Okay, so, and again, I'm not going to explain the little things anymore. I'm going to move away from that. But please make sure you understand every single step. If you don't understand why I do something, make sure you ask me or you ask someone else. But even before that, try to figure it out for yourself. So, this is just one way. Okay, do you remember that formula? Okay, so that formula, when you take a square root, the derivative of a square root, you don't want to go blank to the 1/2 anymore, because that's going to complicate things. It's much faster if you just know this, and then this goes inside. Okay, so that is the derivative of this part. So it ends up being okay. That's the left side. Derivative of that is just 1 minus 2. Okay, you need a y prime, because derivative of 2y is 2 dy dx. And dy dx is all turned to y primes. dx is turned to 1s, so that's why you didn't have to write it. Okay, now, guys, when you see this problem type on the test, there's going to be one of them, similar level of difficulty to this. Don't bother solving for y prime at this moment, because that is going to be a mess. Instead, plug this point in right now. And then you'll get just coefficients. You'll just get y prime terms and constant terms, and you could just solve like a linear equation. So plug it in at this point. All right, now honestly, I think I started doing this just to help students maybe see things better, but this is actually turns out to be easier for me if I leave blanks. But you don't, I know a lot of you don't do that, but I mean, you don't have to, it just helps me. Oh, okay, that's actually not that bad, right? When we do this, okay, now 4 is going in for x, 1 is going in for y. So where did I see x's? I'm putting a 4. So there was an x, there was an x, and then for y's I'm putting 1s, okay? And then this ends up being on top, sorry, I'm talking again. My prime, whoops, that's important. Alrighty, I'm multiplying both sides by 4, okay, or cross multiply, however you want to think of it. 3/12 is 4th. Dun, 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 dun. Okay. Then, all right, so we have seen these types of problems. Okay, these first 2 types of problems. Now we'll see this type of problem. So finding this is, okay, this is really hard to even say. Like d squared y over dx squared, you don't have to say it, you don't have to read it like that. You just read y double prime, or the second derivative of y with respect to x. But this is Leibniz notation for the second derivative. So you're going to be asked to do 2 of these types. So, the first one, and the level of difficulty will just increase. Right, the first one, it won't be too bad, and then the second one, you'll have to be more like on your game. So here's this, page 2, number 48. So we're going to find the second derivative of that. So it's this one here. Okay, and yeah, so derivative of this is, all right, now you guys, this is really optional. I guess I'll do it though. Okay. And then solve for y prime. Okay, that is y prime. We want y double prime. Okay, well, okay, so these directions said to find y prime and then to find y double prime. On the test, it's just going to say, like, find y double prime in terms of x and y. But you have to find y prime to get this anyway. So these directions are a little bit, maybe a little bit redundant. I guess they just want you to state both of these clearly. But yeah, you have to go through y prime to get to y double prime anyway. So here's y prime, and now y double prime. I need quotient rule. So minus over that squared. Okay. Yes, a lot of times when you're finding y double prime, I've noticed you will end up having to use quotient rule on the second derivative, because you'll get a fraction for the first derivative. Okay, so y double prime equals, that's 1 minus x And then the very last thing you do, they want this in terms of x and y. So you need, okay, so this y prime, I have to replace that with an expression in terms of just x and y. So I need to know what is y prime. And y prime is that. So x over y goes in there. Okay. And honestly, for AP Calc, you don't need to simplify. So you can just leave it like this. You can leave it like this. Your book, however, when you go to, practice problems and then look at the book's solution, they're going to simplify this. So maybe let me real quick just do that. But on the test, no, okay, on test, stop here. Okay, stop there because you don't want to go too far and then make a little mistake. But just for the book's purposes, let me just real quick give you a little refresher. So this is y double prime. Okay, and that's really that. And then you get common denominators, so it's y squared minus x squared over 1. Okay, and if you couldn't follow some of that, if I went a little bit too fast, make sure you understand, like this sort of algebra, you should be able to do with fluency. And if you could last year, so if you can't now, we just need to do a little bit of practice. But okay, so make sure you understand how to do that. But on the tests, stop here. You don't have to go further. Okay, here is the second type of problem, or no, same type of problem, but the second one. Okay, so we're doing this. We're on the second one. Okay, so, oops. All right, and that is not necessary. You don't have to do that. Okay, product rule here. So, okay. Gotta get these on the same side and the other ones on the same side. So, did I do that right? Yeah. Because I subtracted, yeah. All right, and then I divide. Oh, and I can also, all right, so this is gonna end up being, because I could factor out a 2. I'm sort of doing this like, and then I get down here, I factor out a 2, x minus y. Oh boy. Oh my gosh. Oh, never mind. I thought these canceled. Let me make sure I'm right. So this was 2, shouldn't have skipped a step. This is 2x minus 4y. I factor out a 2, and that's x minus 2y. I'm just talking out loud for myself. And then I'm dividing by this, but I factor out a 2 there. 2x minus y. All right. Cancel those. And then we need the second derivative. So quotient rule. Okie dokie. So x minus 2y. Okay, so the derivative of this is 1 minus 2y prime. That comes down. Minus this comes down. And then the derivative of this is 2 minus y prime. All over 2x minus y squared. Alrighty, and now the very last step is that you're going to replace the y primes with that. And then you're not going to simplify, you're not even going to touch it after that. Yikes, this is a mess. Alright, so this is 1 minus 2 x minus 2y. Okay, I'm just plugging that in. Yikes. All over. Yeah. Alrighty. So that's that answer. Wow. Messy. Okay, so now the next, that's actually pretty long, but that level of difficulty really we should be able to, you can do it. You totally can. It's just a matter of practicing. And, okay, so now we're going to do this. Because we just did 2 of those ones. Now we'll find a second derivative at a point. And for this, we can turn to page 3, number 60, down here. Okay, now this says find the first and the second derivative at that point on the graph of this. All right, so we're just going to do the second derivative though at that point. So we'll find the first derivative and then we won't plug 0, 0 into it. We'll just use the first derivative to find the second and then plug 0, 0 into that. Okay, so at 0, 0. All right, we want the second derivative. Okay, so first derivative. So 12. Okay, now. Is this right? 12. Yeah. Oh, yeah. Like you always, every example I'm doing of the second derivative, you always got to use quotient rule. But it isn't always that way. Okay. Okay, so this is 1 minus 12. Okay. Well, thank goodness we're just plugging in 0, 0. And this 4y, right. Okay. No y primes here. there's a y prime. All right, so plug that in. Negative 24x. Okay, and then y prime, oh my god, is 1 minus 12x squared over 2y squared minus 1. Okay, and then we plug in 0, 0. So, you're plugging in 0 for x and y, so this whole thing cancels. This is gone. This ends up just being 1. Like this term is gone. So that's just 1. All right, so this is 0. That whole thing is 0. This whole thing is just 1. That whole thing is just 1. And then this, what? Is it 0? Yeah, because y is going in, shoot. Oh my god. So y double prime, so that's, that doesn't mean a horizontal tangent though, because the second derivative is not the slope of the tangent line. We haven't even talked about what that is. The first derivative is the slope of the tangent line. The second derivative is something entirely different. Okay, which we will discuss, I think, next unit. Okay, next. Alrighty. Okay, finding the equation of a tangent line at a given point. You can expect to see a problem like that. Page 3, number 56 has one, and it's, okay, there's the graph of this, and we want the equation of the tangent line at that point. So that is this one down here. All right, this is page 3, number 56. So here is the graph. There's the tangent line. Oh, the bell's gonna ring, shoot. And we want the equation of that line. That's what we want. Okay, to be continued because the bell is about to ring.